Yeah, all right, in this lesson we're going to get started with Algebra 1. I went over this in our arithmetic class, but I'm going to go over it again quickly just because there might be people who watch this video who don't take arithmetic and they didn't see this already. But what we talked about was high school mathematics. Just bear with me as I go through this. We said in high school mathematics there are 4 years of mathematical studies. Each year has 120 hours of instructional time. That means time supervised by a teacher. 120 hours multiplied by 4 years means that there's a total of 480 hours of mathematical studies for a quality high school diploma. Not bottom of the barrel, not lowest requirements, but a good college prep high school diploma. And when we talk about those years of study, the first year is usually Algebra 1. The second year is usually spent on geometry, modern geometry, not classical geometry. The third year is a review of Algebra 2 that gets into a little more detail. And then the fourth year is usually a study called trigonometry, and some schools call it pre-calculus, and they combine it with some other studies to get ready for calculus. And then the highest high school math that's ever studied is calculus. And calculus, you really would never study that unless you were actually interested in being a mathematician or applying to a scientific, engineering, technical college that really was going to demand mathematical studies from you, okay? Most students won't study calculus. So those are the 5 common high school math courses. Most students will only get through 4. Most students would stop with pre-calculus. And what I explained in my other video is the SAT test, which is required for colleges, only requires geometry and algebra. So trigonometry would not be included, or is not included on the SAT. So in high school, these 3 courses, Algebra 1, Geometry, and Algebra 2, along with arithmetic, are the most important high school studies because they're going to determine your SAT math score. Okay? And we'll study the SAT. We'll get ready for the SAT when we need to. That's an important test that most colleges, most selective colleges require for admission. You have to get a certain score to get into a good college. So Algebra 1, Geometry, Algebra 2, and then trigonometry is usually the 4th. And for students who are advanced, they can get into calculus. Usually students who get into calculus studied algebra before high school, like 8th grade, 7th grade. They got into algebra. Okay? So that's the normal high school course. What I said we're going to do in the Classical Liberal Arts Academy is we're going to add some focus on arithmetic because most students never learn it. So we're going to study Modern Arithmetic 4, and then we'll get through as much of this as you want to. We'll just study through the books. All right? But in this course, we're going to get started with Algebra 1. And so the first thing that we need to talk about in an introduction, I'm going to erase this now. The first thing that we should talk about is what is algebra? It's a weird word to begin with. What is algebra? What is algebra? Algebra is a mathematical science, so we know that it's a study of quantity, right? Because we learned that mathematics is the study of quantity. Algebra is a study of quantity. It's related to arithmetic. It's not geometrical. It's not related to the study of magnitudes. It's related to the study of number or multitude. But it's different from arithmetic. And this is what's important to understand. Arithmetic is easy and simple when you know the numbers that you're dealing with. Like if I ask you to add 26 and 43, that's arithmetic. We know the numbers, we just have to find the solutions, right? If I ask you what's the square root of 64, that's arithmetic. If you know how to find square roots and you're given the number, it's not hard to find the solution. That's arithmetic. In arithmetic, we work with specific quantities, specific numbers, and find solutions. You got that? That's arithmetic. You've studied that your whole life. In algebra, we do something different. Because there are situations where we don't just want to find the answer to a question. We don't just want to find the answer to a problem. We want to actually understand how we can find the answer to a problem when the numbers change. You see what I'm saying? What happens if the numbers change? So let's just use an example. Let's say you want to start a business. You want to start a carpentry business. So you're going to be building sheds for people, and they're going to pay you to build sheds. We'll just make up a project, okay? You're going to have to figure out the cost of all your materials for the shed. Then you're going to have to, well, I should say cost of materials, right? You're going to have to buy wood and screws and nails and all this stuff to build the shed. Then you're going to have to figure out how much time it's going to take you to build the shed. And you're going to have to figure out how much money you're going to make per hour to do the work to build the shed. And that, when you add these numbers together, that's going to give you your total cost. What it's going to cost you to build the shed, your time and materials. And you're going to use that cost to figure out what your price should be. What are you going to charge someone? What are you going to charge someone for a shed? Right? So to run your business, you're going to have to figure out this formula for your business. Because when you're done, you want to end up with profit. You know what I mean? If it costs you $1,000 to build a shed, you're not going to charge $1,000. Especially if you have to pay other people to work. This isn't necessarily your money. It might be people who work for you or with you, right? You're going to have to figure out how much to charge so that you can make some profit. That's what the business is for, right? But here's the problem. Every time you go to Lowe's, the prices are all different. The wood changes price, the screws change price. Prices always change. And the time it takes for you to do the work can change. Right? If it's 110 degrees outside and you can only work from 8 o'clock in the morning until noon, and then you have to stop because it's too hot, it might take you 6 days it might take you a lot longer to get the work done than if you could just go and crank out work for 10 straight hours because the weather's nice, right? You understand? Okay? The time that a job takes might change. What you pay people or what you get paid might have to change depending on who's working with you. Like if I take Daniel to work, I'm going to pay him $1 an hour because he doesn't do any work. But if I take David to work, I might have to pay him $10 an hour, right? So the time can change, the rate of pay can change, the materials can change. Your price is going to change, okay? Because of all of these different things that change. And so to run your business, people, let me just say this. Different customers are also going to ask for different things. One customer might want a set of stairs put on the deck. One customer might want planting boxes built on the deck. Another customer might want 2 staircases built on the deck. So every deck is going to change, and this business is going to get complicated because you always have to make sure you can make a profit. And all of this stuff is going to change. So how can you run a business? How can you set prices? How can you advertise and tell people what the deck costs? All of the numbers are changing. You understand that? Okay, so you see the problem that develops? What I want to know, if this is my business, I want to come up with a formula. I want to come up with a formula that gives me an idea of what I can charge and what things will cost. And if this goes up, this automatically goes up. And if this goes up, this automatically goes up. I want to have a formula that is basically the rule of my business. Do you understand that idea? Okay, I want to have a formula. And I was talking to you about this in arithmetic. Like when you go to Amazon and you wonder, how do they figure out how to run this business? It's very complicated formulas behind the scenes. Well, even a carpenter has to do that kind of math work. If you have a dairy, the milk and the feed, everything is constantly changing. And you have to figure out when someone calls and says, how much is a gallon of milk? You have to give them a price, and you can't just make it up. You've got to make sure it's a real price and that you make a profit, or you're going to end up losing money in your business. So because different quantities can change, you need more than just arithmetic. You need to be able to figure out how different quantities relate to each other when quantities change. Okay? And we call them formulas. And here are some more examples. Let's say that there was a hill in a battle, and on this hill they had a cannon set up in a certain war. And the enemy camp was down here. Okay, let's say they had this little camp set up down here. And we wanted to know if we were going to fire this cannonball, what angle would we need to point the cannon for the cannonball to fly and drop right on that location? That's complicated. We have to know how fast the cannonball moves out of the cannon. We have to know how far the camp is from the cannon. We have to know how high the rise is, or the drop from the cannon down to the camp. You see what I mean? So there are all these different quantities, and they can change. They can change. This camp, the next day, this camp might move 100 feet closer to the hill. Well, now everything's different. And so for this guy shooting the cannon, to try to figure out how he can shoot that cannonball so it falls right into that camp, he has to have some kind of rule that allows him to make that calculation. Same thing is true for a sniper in modern military. A sniper gets one shot, because if he misses, the shot will be heard and it's no longer a secret. He gets one shot, right? So all of these different things have to be calculated, and what mathematics allows us to do is come up with rules or formulas that we can use to solve problems where the quantities can change. Do you understand that? So if I don't know what the cost of materials is going to be, because the prices at Lowe's always change, I don't know what the price is going to be. I can just use a letter. I can say, okay, W is the price of wood, and S will be the price of screws. Okay? I don't know what they're going to be. So the cost of materials, M, is equal to the cost of wood plus screws. That's my cost of materials. The cost of labor is equal to time times the rate of pay. So my labor is equal to time times the rate of pay. So my total cost of my work is going to be M plus L. Right? That's going to be my cost. You see how we're using letters? We're using letters. Daniel, follow me here. We're using letters as symbols of quantities because the quantities are not known. They're going to change. So we're not going to talk about $8 because we don't know what the cost is going to be. We simply are going to use a letter to represent that quantity because we don't know what it's going to be. And now I know that my cost is equal to material plus labor. Material is equal to the cost of wood and the cost of screws. The labor is equal to time times the rate of pay. That gives me this for my cost. Now I'm going to say the price that I'm going to charge for my shed is going to be, and I'm going to come up with a formula, okay? It's going to be 2 times C. So my price is going to be 2 times the cost. And that's how I'm going to make my profit. So if anyone asks, how much does a shed cost? The answer is 2 times C. You see what I'm saying? And if you call a carpentry company and you ask, how much does a shed cost? They're not going to give you an answer because they don't know. What they'll do is they'll say, listen, we'll come to your house and we'll take measurements and then we'll give you an estimate. And that's how it works. And when they give the estimate, this is what they do. And then they give you a price, and then you can decide if you want to buy it or not. But they can't just give you a price, because if the cost of wood goes up, their price has to go up. You understand that? Okay? So what they'll do is they won't give a price. They'll list something like, we build wood decks, and they'll say starting at, you'll see prices listed as starting at $1,500. Because that's the lowest it's ever going to be for a small deck. Or because they don't want to waste their time building a deck that's smaller than that. You see what I mean? But getting this formula, the price of my shed is equal to 2 times the cost. That's what the businessman wants to figure out. And if you own a different carpentry shop, you can say, yeah, well, the price of our shed is only 1.5 times the cost. Now our formulas in our businesses are competing. You see what I mean? And I have to figure out, can I go that low? Or do I have to keep my prices where they are? And you see that this figuring out the formula is part of the challenge of doing business. Okay? Do you understand what this means? How these letters are used to represent? That's what algebra is. It's simple. Algebra is simple if you keep it practical. You understand that the reason we use W is because the price of wood can change. We don't have a dollar number. The reason we use M for material is because these numbers can change, and we don't necessarily know what that number is yet. But this allows us to figure out this formula, and this is what's really useful for us. because now I can do business. Okay? And somebody says, hey, can you cut that price down a little bit? And I can say, no, it's actually impossible for me to cut the price. Or I could say, yeah, I can cut the price a little. Because I have a formula, and I know there's a little bit of room that I can play with. Okay? But if you can understand this, you can understand algebra. Because that's all it is. It's just using letters. It's using letters to represent quantities that we don't necessarily know. You understand that? So that we can understand the relationships between different quantities, even if we don't know what those quantities are. Okay? And let me give you another example. A simple example. How does this help us to understand relationships? Let's say there's a car, fancy moon-shaped car, and it travels a certain distance, and we'll label that distance D, in a certain amount of time. And I'll put a little clock here. And we'll say the time is T in seconds, or let's say hours, right? And the distance is miles. I want to know how fast this car is moving. I want to know the speed of the car. Okay? There's a formula that tells us the speed of the car, and all of you know this formula. The speed is distance divided by time. The speed is the distance in miles divided by the time in hours. And that's why the speed is miles per hour. That's the speed. All right? So anytime you say, we're driving 60 miles per hour, we're driving 20 miles per hour, you're giving a number that comes from a formula. And the speedometer in the car is constantly calculating this formula. And have you ever asked yourself, how does it do that? How does the speedometer know how fast we're going? How does it know? How is the speedometer in the car measuring the distance and the time? How in the world is it doing that? You just look at the speedometer and read the speed, and you don't think about what it's actually doing. It's constantly dividing the distance you're traveling by the time you're traveling, and constantly giving you a number that's the answer to that division problem. Okay? You understand that? Not so simple. Now, on my bike when I was a kid, I had a speedometer. And the speedometer connected to the front tire. And what it would do is the speedometer was based on a formula that knew how big the tire was. And so it knew that every time the tire went around once, it was like 3 feet. You see what I'm saying? So it could calculate the amount of times the tire went around, and inside the speedometer was a mechanism that did the calculation that showed the speed. Okay? But do you understand this formula right here? Tells us speed. Speed is equal to the distance traveled divided by the amount of time traveled. Understand that? Now here's what we want to understand. Okay? Let's see how smart you are. If the time stays the same and the distance is greater, what happens to the speed? If the time stays the same and the distance is greater, the speed goes up. Right? What happens if the distance stays the same but the time is longer? What happens to the speed? The distance stays the same, the time is longer, the speed goes down. So do you see what this shows us? It shows us that there's a relationship between speed, distance, and time. You understand that? You understand the idea of a relationship between speed, distance, and time? That there's a relationship between these three quantities. And it doesn't matter what the numbers are. That relationship is always true. It doesn't matter what the numbers are. If the distance increases and the time stays the same, the speed goes up. If the distance stays the same and the time goes up, the speed goes down. There's a relationship between these three quantities, and algebra tells us what that relationship is. You see that? When you sit there and try to figure out the answer to that question, you're using algebra. That's what algebra is. Okay? So when people say, algebra's stupid, when are we going to ever... We use algebra every single day. Every day we use algebra. Or maybe we don't use algebra, but the speedometer uses algebra. Okay? When you go on the website at Amazon, the website's using algebra to calculate your prices. It's always running. Anytime we want to understand a relationship between quantities, where the quantities can change, we use algebra. Okay? You understand that? So algebra is the study of the science of quantity that doesn't relate to specific known quantities, but that relates to changing quantities. Okay? And that's why when you start learning algebra, what gets everybody confused is why there's letters in algebra. Why are we using letters? Because the quantities are not known. And it doesn't necessarily matter, because we're trying to understand relationships in algebra, not just find solutions. If I already know the quantities, think with me. What's going to happen is your brain is going to get tired. You just have to keep working. When we use the formula, and if we know the quantities, like I know the distance and I know the time, then I use arithmetic to solve the problem. That's not algebra. Once I know the numbers, I'm not using algebra anymore. I'm using arithmetic. Understand that? But when I don't know the numbers and I'm trying to figure out relationships, I need algebra to help me, to study the relationships. Okay? So, for example, to study physics, if you want to study physics in science, you're going to have to know algebra, because physics is based on algebra. So if you don't learn algebra, you're not going to understand physics. And if you think physics is cool, like that example I gave you of the cannonball, that's physics. When I was a teenager, I thought physics was cool. You could figure out all kinds of stuff. To be able to do that kind of calculation, you're going to have to be very good at algebra, because that's what it is. All right? So let's get to our textbook here. I hope that's a good enough introduction for algebra. Let's get to the textbook. Let's start going through definitions. Now for you younger guys, you might struggle when we get into algebra, when we start getting into the real stuff, because you're still studying arithmetic. But there's no reason why you can't learn definitions, right? Definitions, you don't have to be 25 years old to study a definition. It's just memory work. Okay, so let's go through the definitions together. And if you younger guys get to a point in our studies where you just find it's getting too difficult too fast, we'll just take a break for you. Okay, because you have lots of years to do these studies. But you can get a head start and learn these definitions. So look at the definitions on the first page. We're just going to read through these together. In algebra, quantities are represented by letters of the alphabet. Everybody gets confused about that, but I just showed you how simple it is. Okay? In algebra, quantities are represented by letters of the alphabet because we don't know what the quantities are. That's why. Quantity is anything that is capable of increase or decrease. We already know that. We studied that in arithmetic. Quantity is anything that is capable of increase or decrease. Definition 3, quantity is called magnitude when considered in an undivided form. Pay attention because I want you to understand this. Quantity is called magnitude when it is considered in an undivided form. Remember I told you today in arithmetic, I said a magnitude is 1. Remember that? A multitude is a collection of separate things. And a magnitude is one thing. All right? Definition 3. Quantity is called magnitude when considered in an undivided form as a quantity of water, like a pool of water or a bucket of water. That all the water inside the bucket is a magnitude. It's a certain amount of water. You say how much. You don't say how many waters is in there, right? We don't look at a bucket and say, whoa, how many waters are in there? We don't say that. We say how much water is in there because it's a magnitude. Okay? Definition 4, quantity is called multitude when made up of individual and distinct parts. Distinct means divided or separated. Quantity is called multitude when made up of individual and distinct parts. So you should know what quantity is, and you should know that there are two kinds of quantity. You should jot this down. You should know what quantity is, and you should know that there are two kinds of quantity, multitude and magnitude. And you need to ask yourself, do I know what quantity is? Do I know what magnitude is? Do I know what multitude is? And if you don't, you need to study and figure it out. What is quantity? What is magnitude? What is multitude? Rule number 5, or definition number 5. One of the single parts of which a quantity of multitude is composed is called the unit of measure. So one of the parts of a multitude is called a unit of measure. If we talk about a flock of sheep, it's a multitude, okay? A flock of sheep. What's the unit of measure of a flock of sheep? You know? One sheep, okay? The unit of measure is what we call one. When we look at a quantity, a multitude, and we ask how many sheep are there, the unit is one sheep. And then you count how many units, how many sheep are in that multitude. Okay? The unit of measure is the thing that's counted. Get that? The value or measure of any quantity is the number of times it contains its unit of measure. I have to explain this a little bit because the definition can be a little difficult to understand. That rule there, the second part of rule number 5 says the value or measure of any quantity is the number of times it contains the unit of measure. That sounds like gibberish. Let's imagine that we have a pile of pennies. Okay, we have a pile of pennies. This is a multitude, right? This is a multitude. It's a collection of distinct parts. It's a multitude. What is the unit of measure of this multitude? What is the unit of measure? It's okay if you get it wrong. What's the unit of measure? One what? Penny, okay? Make sure a penny is the unit of measure. right? Not one, but 1 penny. Okay? This is a multitude of pennies. The unit of measure is that thing which we call 1. The unit of measure is what we call one thing in the multitude. So if it's a multitude of pennies, the unit of measure is the one thing, the penny. If it was a flock of sheep, the unit of measure would be 1 sheep. Okay? That's the unit of measure. That's the thing that we call 1. The thing that we call 1 is the unit of measure in a multitude. Now the second part of that rule, or that definition in number 5, is a little confusing. It says the value or the measure of any quantity is the number of times it contains the unit of measure. So if I were to ask you, what is the value? What is the value of this quantity? What is the value? Or, this means the same thing. What is the measure of this quantity? The answer, and these are the same thing, the value or the measure. These are 2 different words that mean the same thing. The value of this quantity is the number of how many times this quantity, this multitude, contains the unit of measure. The value is the number of times. The value of the multitude is the number of times it contains the unit. You understand that? That's the value. So if we were to look at this multitude right here, and we were to say, this isn't a multitude, it's a multitude of pennies. The unit of measure is 1 penny. Is that clear? Okay? We just have to make sure we get all these definitions and things clear. Because like I said, this is the kind of stuff that people don't take time to study. And it's why they struggle later on. This is a multitude. It's made up of units. The unit of measure is 1 penny. If we were to ask, what is the value of this multitude? What is the value of this multitude? What is the measure of this multitude? What we're asking is, how many times does this multitude contain the unit of measure? 1 penny. Okay? And we'd have to count. So here's 1 penny, 2 pennies, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. This multitude contains the unit of measure 18 times. So the value of this multitude is 18. That's what a number is. And this is why this is important. A number is the value of a multitude. A number is the value of a multitude. You got that? This is basic stuff, but this is the kind of stuff that students often really don't understand. This basic stuff. What is a number? A number is the value of a quantity, of a multitude. A number is a value. It's the number of times that a multitude contains a unit. That's what a number is. Okay? That's what this 5th article is describing. It just does it in words that I think are a little difficult to follow. One of the single parts which a quantity of multitude is composed is called the unit of measure. You should understand that now. 1 cent is the unit of measure of 3 cents. The value or the measure of a quantity is the number of times it contains the unit of measure. That's the value of the multitude or the quantity. Rule number 6. Notice, and this is important, this is what you have to pay attention to because this is where students get lost in these textbooks. Rule number 5 there, article number 5 is talking about multitudes. And if you look at article number 6, it changes and talks about magnitudes. Rule 5 is about multitudes. Rule 6 is about magnitudes. So make sure when you see that, if you read article number 6 there, and you say, in quantities of magnitude, you have to stop and ask yourself, what is a magnitude? It was defined up in article number 3. You learned what a magnitude is in article 3, and then we're talking about magnitudes in article 6. If you didn't learn what a magnitude is in article 3, you're not going to understand what number 6 is talking about. You understand that? And when you're confused on number 6, it's because you didn't learn article 3. Learning is that simple. When we have good textbooks, it's that simple. If you don't learn article 3, you're not going to understand article 6. Okay? In quantities of magnitude, when there is no natural unit, now I know you don't know what that means. In a magnitude, there is no natural unit. What in the world does that mean? I know that you don't know what that means. So let's look at it. You have to work with me. You have to work. You want to understand these things, you have to work. Study is work. There's no such thing as a smart person. Great students have to work. The word student means one who is seeking, one who is working. That's what a student is. If we take a multitude, it's a quantity of divided parts. There is a natural unit. The natural unit of a multitude, this is a multitude. The natural unit of the multitude is the one thing which we're counting. That's the natural unit for a multitude. So if this is a multitude of pennies, the natural unit of a multitude of pennies is 1 penny. Okay? If this was a herd of sheep, the natural unit of a herd of sheep is 1 sheep. That's the natural unit. If we take a magnitude, so instead of a multitude, if we take a magnitude, and I'll just draw, let's say, a cube. If we have a block, and I want to know how great is this cube, how do you measure it? There's no unit. This has a natural unit, right? When I say multitude of sheep, we all know what the unit is. It's 1 sheep. But if I were to take a cube, a block, let's say a block of wood, and I were to say, how big is this block of wood? There's no way to answer that question because a block of wood has no natural unit. There's nothing to... How do you measure the size? How do you measure the size? We don't know. What we have to do with a magnitude, if we want to measure a magnitude, is we have to invent a unit. We have to make one up. So if the block was this big, imagine this was the real size, and we had to measure how big this block was. What do you think a good unit would be to measure this block? We want to know how big it is. What do you think a good unit would be? Inches, right? Inches is an artificial unit. Is there anything in this block that requires us to measure it in inches? No, right? I could measure it in chalks. I could say the unit is 1 chalk. And so I'm going to say, okay, it's 1, 2, 3, 4, 5 chalks wide, and it's 5 chalks high, and it's 5 chalks deep. And I could say, this is 5 chalks by 5 chalks by 5 chalks. Why is that not a good unit to use? Why is that not a good unit to use?
Because not everyone has the same thing.
Because the chalks can be different. Right? We don't know what a chalk is. Not everybody has my chalk, so we can't measure everything in chalks. So that's not a very good unit to measure, but it's okay. Okay? We normally choose units that we have all agreed upon. The measuring tape tells us what the unit is, and then we all agree to use that unit. You see what I mean? In another country, though, they might not use inches. They might use centimeters in the metric system. Okay? There's no natural unit. You can use whatever you want. When I make measurements out in the garden, I use my feet to measure because I don't care if anybody else measures. It's just for me. If I want to know how far this tree should be planted from the barn, I'll just walk it off and count how many feet, literally, my feet, it is from here to there. And then I'll go to the other side of the barn and I'll walk and I'll count the same number of my feet. So it's okay if I'm the one doing the measuring. I can make my feet, my unit of measure. I can make chalk my unit of measure. I can make my hand the unit of measure, and people do that, right? How big was the ark? How was it measured? Cubits. What in the world is a cubit? You know what a cubit is? It's the distance from your hand to your elbow. What's the problem with that? We all have different length cubits, right? So that's one of the problems with units. But when we're going to measure a magnitude, we have to make up a unit because there is no unit in the magnitude. Do you understand that? In a multitude, we all know the unit. It's the individual thing. But in a magnitude, there is no unit. We have to make one up. And if we have to share measurements, we all have to use the same measurements, and that's why we have rulers and tape measures and scales and all that kind of stuff. You understand that? So you can go to Lowe's in California and buy a tape measure, and it's exactly the same as a tape measure in North Carolina. You can call somebody on the phone and say, you need to cut this piece of wood 16 inches long and 2 feet wide. And he can cut the exact same piece of wood on the other side of the country. Okay, that's when we agree on units. But we have to make up units to measure magnitudes. That's what Article number 6 is explaining. All right? Now listen to Article 6. In quantities of magnitude, where there is no natural unit, you understand what that means now? Where there's no natural unit, it is necessary for us to fix upon an artificial unit, a unit that we make up, artificial unit, as a standard of measure. And then, to find the value of the quantity, we ascertain how many times it contains that unit of measure. You understand that? Okay, I hope you do. It goes on. To measure the length of a line, take a certain distance called a foot, and then applying it a certain number of times, let's say 5, it is found that the line is 5 foot long. In this case, 1 foot is the unit of measure. So I think we understand that now. Number 7, Article 7. The numerical value of a quantity is the number that shows how many times it contains its unit of measure. The numerical value of a quantity is the number that shows how many times it contains the unit of measure. For a line that's 5 feet long, the numerical value is 5. Notice that it's not 5 feet, it's just the number, 5. If there's a line that's 5 feet long, the numerical value is simply 5. That's the value, the numerical value. Just the number of times it contains the unit. The same quantity may have different numerical values. The same quantity, let's see how smart you are. The same quantity may have different numerical values. How would the same quantity have different numerical values? How could this quantity, this magnitude, this block of wood, how could it have different numerical values? If something changed. If what changed? The unit of measure. Right? If the unit of measure changes, then it has a different numerical value because the units are different. If I measure how many inches, let's say 5 inches, and then I measure how many centimeters, I'm going to get a different numerical value. Even though the magnitude is the same, the numerical value is different because the units are different that I use to measure. This is simple. This is really simple. I think you're being mesmerized by the words a little bit, and this is something that's really simple. If you use different units, the number changes. It's not that complicated, right? So that's number 7 there. Number 8, a unit is a single thing. A unit is a single thing of an order or kind. And I'm just going to say this. I guarantee that one or more of you struggles later on in algebra, and the reason why you struggle is back in these silly definitions. Because what you're going to struggle with later on is right here in lesson 1. Okay? You have to make sure you study this to master these definitions. Because everything else is going to assume you know what these words mean and you know these definitions. A unit is a single thing of an order or kind. A single thing of any kind is a unit. That should be clear. A number, article number 9, a number is an expression denoting a unit or collection of units. A number is an expression that denotes a unit or collection of units. It says a unit because it can be one. It says a collection of units because it can be more than one. Right? The number 2 is a collection of 2 units. The number 3 is a collection of 3 units. 1 is just 1 unit. And then we learn in Article 9, numbers are either abstract or concrete. Either abstract or concrete. And I'm sure you don't necessarily know what the words abstract and concrete mean. You know the word concrete, you think about cement. Okay? And that's okay to think about it like that because it kind of relates to the idea. Concrete means something that actually has some kind of substance. It's material. It's concrete. A concrete number has some substance to it. It's definite. It's something that's known. It's a concrete number. Like 7 inches is a concrete number. It's a number and a unit. Do you understand that? A concrete number is a number and a unit. You know the number and you know the unit in a concrete number. An abstract number is just a number with no unit. It's the number by itself. Abstract means drawn away. It means to draw the number away from material things. So you're talking about just the number itself. Not 7 some things, but just 7. The idea of 7. That's what it means to be abstract. Abstract means it's just in your mind, not necessarily in some quantity of things. An abstract number denotes how many times a unit is taken. It means just the number, the value. Just the number. The idea of the number itself. A concrete number denotes the units that are taken. So $4 is a concrete number. 4 inches is a concrete number. 11 is an abstract number. $11 is a concrete number. 500 pounds, is that concrete or abstract? 500 pounds. Concrete or abstract?
Abstract.
No. It's concrete because it has the unit with it. 500, is that abstract or concrete? 500. Abstract, just the number, just the idea of the number. 20 feet, is that abstract or concrete? It's concrete. It's the number and the unit. 64, abstract. It's that simple, okay? If the unit is included, it's concrete. If there's no unit, just the number by itself, just the idea of the number, that's abstract. All right, so we've gotten through quite a bit of introductory stuff. The only other thing that I think we should talk about, we can wrap up the first part of this lesson. I've got a couple minutes left. Let's just get this done. Article number 12. I already talked about Article 11, so we can skip that. Article 12. There are 2 kinds of questions in algebra. 2 kinds of questions, theorems and problems. These are just 2 simple definitions. There are 2 kinds of questions in algebra, theorems and problems. In a theorem, this is a kind of problem. It's required to demonstrate some relation or property. You have to demonstrate or prove something in a theorem. Okay? I'm just going to leave it at that. In a theorem, you have to prove something to be true. Got that? In a theorem, you have to prove something is true. In a problem, you have to find a value of something. So in a problem, it's like you have to solve the problem. You have to find the value. That's a problem. In a theorem, you have to prove something to be true. Those are the 2 different kinds of questions in algebra. And the last article in this first part, article number 15, we have what might be considered a definition of algebra. Algebra is a general method of solving problems and demonstrating theorems by means of figures, letters, and signs. That's your definition of algebra. So when I asked what is algebra, article 15 tells us the definition of algebra. Algebra is a general method. That means it's general. It applies to all different situations. That's why we use letters, right? Algebra is a general method of solving problems and demonstrating theorems by means of figures, letters, and signs. And these are called symbols. And that's all for this first lesson in algebra. So you have to study these definitions on your own, memorize them, complete comprehension questions, and we'll just build one lesson at a time. But like I said, when kids get into trouble in algebra, it's because they don't know this stuff. They don't know the definitions of the words. It's not algebra. Algebra is simple. It's the details, the simple details that people never learn. And that's what causes them to struggle.